I'll get us started. I'm very excited as we continue throughout the semester that we get to take advantage of some of the expertise on campus. And in this case, we're having Dr. Marlon come speak to us today. So if you're unfamiliar, Dr. Jen Marlon is a senior research scientist at the Yale School of the Environment, the executive director of the Yale Center for Geospatial Solutions, and a lecturer in the Department of Molecular, Cellular, and Developmental Biology. And broadly speaking, her research uses surveys, experiments, and modeling to understand public perceptions of and responses to rapid environmental changes, particularly related to climate and extreme weather events. You have access to the complete bio, but I think that's enough to get us started for why we would be having Dr. Marlon here to speak.
Thank you so much. Thank you for hosting me. Welcome. I'm glad you could make it today. Let me just ask, how many of you have heard of the Yale Program on Climate Change Communication? Anybody familiar? All right, a lot of you. So some of this, I'm going to talk a little bit about that work. So just want to get it. So I want to talk about communicating about climate change and understanding the public and the connections between climate and extreme weather. And this is a picture of the Boston Commons in 1911 that I found on a New England Historical Archive website. They had a very severe heat wave, and of course there was no air conditioning, no fans even really, and so people were sprawled out on the commons trying to get some relief. And there were many deaths associated with this heat wave, and people were running to the ocean, and there are stories of people going crazy from the heat. And it's just, to me, even though we do have air conditioning today and fans, of course, it was kind of a reminder of what it feels like, because it's hard to talk about extreme heat on a day like today. So this will get you in the mood. I will just acknowledge that the work I'm about to show is definitely the result of a big team effort. And so collaborators from the School of the Environment and from the George Mason Center for Communication. So we are already experiencing some changes in New England. And this is a bit of an old graphic, but I really like it because it's from the global climate change impacts in the US from 2009, so a long time ago. But it shows what it's going to feel like under lower and higher emission scenarios in New Hampshire over the coming decades. And so if any of you, has anybody lived like in the mid-Atlantic states or in the Southeast? Okay, one or two. So the climate is already changing and it's going to increase more rapidly in the coming decades. So you can see, like, just projecting out a couple of decades, there's not a huge change maybe. But as you get further into the future, the changes are going to become more and more dramatic. And so the impacts projected for the Northeast, as you all are very familiar with, I'm guessing extreme heat and associated impacts on health and air quality, increased flooding, decreased production of things like milk and fruit and maple syrup, decreased snow impacting ski resorts and tourism, lobster fisheries. Fishermen are already seeing fish that are native to South Carolina and Long Island Sound now, they're spotting them. So these bullets are from a while ago, but now of course we have more awareness of how virus disease is spreading, insurance rates are going up, so a wide variety of impacts. In the higher emission scenarios, we have impacts potentially that could occur where cities like Hartford and Philly could average nearly 30 days over 100 degrees Fahrenheit. It's very hot and unpleasant. The odds for another Superstorm Sandy to occur next year could be 1 in 2. Today, they're about 1 in 10,000. So the background climate conditions are really changing, even though it's going to be hard to detect among the noise of day-to-day weather. So given all of this, there, of course, is an interest among you all and many here and across the country in helping the public understand these impacts and communicating about them. And the sort of question that is, plaguing all of us in the climate communication sector is, how do we better engage the public? And so this is a little quiz that you can take if you have your phone or computer out and you want to. You can actually go to this bit.ly link and take a 4-question quiz. It's very quick, so you're welcome to. This is a little tool that the YPCCC built to help understand where the public stands in their beliefs and knowledge and risk perceptions about climate change, as well as their support and opposition to climate policies. Because one of the first rules of effective communication is to know who you're talking to, know your audience. And so this is one of the tools that we use to learn about who we're talking to. I'm going to give you a minute while you're doing that. Oops. You can see that. Okay, so after you take this 4-question quiz, you end up with a segment score. And this tool is based on nationally representative survey data of people across the US in every state. What happens is we ask you some questions about what you think about climate change, and then you get a label, or you're put into a group. So alarmed people, as it sounds, are people very worried about climate change, interested in taking action. The opposite side of the spectrum are people who are dismissive, who say this is a hoax, this is not happening, the planet's not even warming. People in the middle are actually have different levels of concern and engagement. And so the concerned think, yes, climate change is real, it's a problem, but maybe it's not urgent. The cautious don't know if it's warming or not. Is it human caused? Is it, volcanoes or solar variation, something like that? They don't really know. The disengaged aren't paying attention at all, really. But if you talk about it, they'd be interested to learn more. And the doubtful are people who are doubtful that it's warming, that the planet is warming. And they think if it is warming, it's like El Nino or natural cycles. It's not anything to do with human activities. So how many of you think that most of the public is in one of these 3 groups? More than 50% are in one of these 3 groups. Anybody think that? The most of you, okay, a couple, 3, 4. Who thinks most of the public is up on that side? Yeah, okay, more. So you are aware. So that is the truth. In fact, more than half of Americans are either alarmed or concerned. You have somebody raising their hand. I don't know if I'm. Okay, so we have most of the public, more than 50%, are alarmed or concerned. These groups are actually quite small. Only 11% of the public are dismissive. I know in the current context and in the current media situation, political situation, it may seem that this is not right, but this is right. This is based on rigorously conducted nationally representative surveys, as I mentioned, Democrats and Republicans. But having these data are important because there is a broad misconception that there are way more people in these 2 bubbles than there are on the other side of the spectrum. And so that's what I mean about knowing your audience, because for most Americans, they think these bubbles are really big because these groups are very loud and organized and well-funded, and maybe they are overrepresented in Congress. And so they get a lot more attention. But the reality is most people really are concerned about climate change, and most people do want more action. And so understanding where the public stands is helpful when we're trying to engage people, because there are different conversations you want to have with people based on where they are. So if you're speaking to someone in the alarmed and concerned group, they want to know what are the solutions, what can we do to address the problem. If you're talking to folks in the middle, they really don't know why they should care. So you need to explain, why does climate change matter to you personally, to your family, to your home and your insurance rates and your children? And then folks over here, how do you know that global warming is happening or human caused? These folks need to know how do we know? And not just the science, but they need to know from trusted family and friends and neighbors and people who they are going to believe. How do we know what we know? And so, and really the underlying subtext when you're speaking to folks in this group is typically, why should I trust you? Do you look like me? Are you from my neighborhood? So there are different challenges depending on who you're speaking with. So this is sort of the context that I wanted to just share with you. That segmentation is one of the most useful tools that the group has produced, and it's nice for setting the stage when you're thinking about communicating with the public. So our surveys, the YPCCC, we do surveys every spring and every fall. They give us a national number like this, 72%. 72% of American adults think global warming is happening. That's pretty good. But as there is going to be very limited or no movement at the federal level, or even backsliding now at the federal level, a lot of the efforts to address climate change and its associated impacts are going to be happening at state and local levels. So we've taken the survey data and we've downscaled it in a way to make estimates for every state, because we need to know, if you want to know your audience, you want to know what they think in your local area. So now we can see that there is some variation. New York, Washington, California, DC have some of the highest levels of people who think global warming will harm future generations, for example. And then lower estimates in places like West Virginia, Wyoming, North Dakota. So that's kind of as you might expect. So that's people's worry about future generations, thinking this is really a problem for the distant future. What about if you ask people, do you think global warming will harm people in the US? The number overall goes down a little bit, 61% nationally now. Those same states are popping out. They've turned blue, which means less than 50% of people in West Virginia think global warming will harm people in the US. 63% think it's affecting the weather. And here we have a map showing the percent who say they've personally experienced the effects of global warming. In most states, it's much less than 50%. California, Washington, Massachusetts have more than half. So this is quite surprising from a scientific standpoint because everyone is actually experiencing the impacts of global warming already, even if it's only that it made the wildfires worse and so they're breathing smoke, or it's affecting food prices because of cascading impacts or worsening flooding. New England, for example, has 60% more extreme flooding events in the past decades, 60% more heavy precipitation, which is the precursor for flooding. So in virtually all these states, we're already experiencing the impacts, but people don't connect the dots. They don't see that. We also were able to use modeling to show how these opinions vary at the county level. And you can see it's even finer grained. There are even really smaller pockets where we have majorities of the public who think that they're personally being affected by climate change. So we have a real challenge. How do we help people understand that this is happening? It's real, it's now, and it's going to get worse if we don't accelerate action. So that context motivated me to dig more into extreme weather, because we experience climate change mainly through extreme events like heat waves, wildfires, floods. That is how we're feeling the impacts of climate change. And so there are some natural questions like, if you experience a flood, does that make you more likely to believe that climate change is real? And does that motivate you to support policies that might reduce carbon emissions, for example? And so the entry point into this is to dig deeper into risk perceptions of extreme weather events and then help people connect the dots between weather and climate. And so we know that risk perception shapes behavior. You know this in studying public health. Examples for vaccination hesitancy, for example, people believe vaccines are riskier than the diseases they prevent, and so that shapes their behavior. Hurricane evacuations, people think, oh, maybe it wasn't so bad in the past, my home is safe. People have misconceptions about lightning, striking twice in a metaphorical sense, which means if they experience a wildfire once, it won't happen again. But that's not true. And so these are just examples that emphasize why we're studying risk perceptions, because they do shape behavior. So I showed you those maps, and I want to show you a little bit about how those maps were created, because this is a method that is very useful for better understanding the variations across space. This is an older paper from 2015 where we introduce a method called multi-level regression with post-stratification, or Mr. P. And we're basically trying to predict people's opinions about climate change and extreme weather by understanding their demographic characteristics, their location and geographic information, political beliefs, maybe not of the individual, but of their local neighborhood or their county. We can combine this data, we can combine our survey data, which has people's personal attitudes, with the characteristics of their neighborhood, and basically predict the percentage of people who hold a certain belief in a certain area. So I'm just gonna kind of quickly give you a sense as to what we're doing behind the scenes to create those maps I showed you. Then I'm gonna apply it to heat waves. So we build a model. Effectively what we're doing, we're building a model where we predict the likelihood that you believe in that climate change will harm you personally. We build a model based on some demographics and state factors, and then there are other factors we might put in, like the percentage of people in your county who voted for Trump, let's say, because that's an important predictor when you're talking about climate. It's a political issue. And then we build a model for 408 subtypes of people. So let's say all African-American women with a bachelor's degree in the state of Mississippi. We build a model for those people, and then all African-American men with a bachelor's degree, we build a model for them. So 408 combinations of all of these groups. And then we have hopefully a good estimate of the likelihood that they hold a certain opinion. And then we go to the Census Bureau and we know, well, there are women in this age group in Alabama. This is how many people there are of that type. And we use these census counts to weight the probabilities of holding that opinion. And the kind of shocking result of all of this is that people are incredibly predictable. We are easier to predict than we think. When it comes to something like an attitude about, believing in climate change, or worrying about climate change, or supporting a policy or opposing a policy even. And the same is true for many specific hazards, it turns out, like the likelihood that you're going to evacuate if you're told to, because there's a wildfire or hurricane or something. Knowing a little bit about you and where you come from, we can basically estimate what you're likely to do or believe. And so this is sort of the basis of all this work. So we built those models, we validated them using independent surveys in Texas, Colorado, Ohio, California, and 2 cities. And if a dot's on the line, it means the model was very, very accurate. These are different questions we asked. How important is climate change to you? How worried are you about it? Do you believe there's a scientific consensus? Have you volunteered to address climate change? Things like that. So some of the questions validate better than others, but by and large, people are quite easy to predict when you incorporate all this contextual information. So after that initial work, the focusing just on climate change, I worked with some colleagues to focus specifically on extreme heat, because extreme heat, as you know, is probably the most deadly hazard, and yet a lot of people don't really understand the dangers of extreme heat. And so we wanted to know, well, can we, the way we did with climate, can we model perceptions of extreme heat? And then can we do it even at the census tract level? So we collected a lot of survey data. We combined many questions about extreme heat to make an index, and we defined it if people didn't really know. just for consistency, and I'm gonna kind of go quickly through this, but basically we validated a new model based just on extreme heat. We did independent surveys in 2 census tracts in Illinois and Southern California. It's very expensive to collect this data, so we can only do 2 census tracts, but we got it within plus or minus 3 percentage points in terms of estimating people's opinions at the census tract level. And what we found was that there's a latitudinal gradient, basically. People in the north are not worried about extreme heat. People in the south tend to be much more worried about extreme heat, which makes sense if you live in Texas or Florida or Southern California. However, we also know that that's not necessarily where the greatest risk of extreme heat is. So because we have census tracts, we could also look within cities. And so we can see that country level gradient is pretty dramatic. There's good variation, but the same extent of variation, about 30 percentage points, can be observed even within a single city, even within New Haven here. This is an index score of like 50, 55, I think, and this is an index score of like less than 20. And so there's a lot of variation within cities. But the problem with this study is that there's just an index score. It's not terribly meaningful. It's just telling you relative worry about extreme heat. It's not really an actionable number. So that leads me to the third study I want to share, which is now focusing on, okay, how can we get more actionable information about extreme heat? And what we really want to know is, are people worried about heat in the right places? Is that where they're really at risk? And so that's what this last study is designed to do. So we took the methods that were building on the previous methods to model the perceived risk of extreme heat. We collected new data. And now we're using observed, or maybe a better word is assessed risk. We're still struggling with this a little bit. This is work that's in preparation. It's in review, actually. So we're using observed or assessed risk from the CDC, and we're going to subtract the perception from the observation or assessed risk to try to see where are the risks and the perceptions aligned or misaligned. So the CDC has this heat and health tracker, and the pattern looks roughly like this. So darker red is places where people have higher health risks from heat. And this is a combination of lots of different data. So there is historical heat and health burden that's incorporated here, which is the number of extreme heat days and heat-related illness. There's sensitivity factors, socio-demographic factors that increase your vulnerability to heat, and then also natural and built environment factors that can sort of mitigate heat in local areas. So we're using this as a measure of sort of the actual risk that people are exposed to and impacted by. And then we're building our own model of how people perceive risks. I'm not going to go into the details. I'm happy to talk about it in Q&A if anybody wants to talk about model development. We can use machine learning algorithms. We can test a lot of different predictors. But basically, we do the best we can to model extreme heat. And to model the perceived risk of extreme heat, these are actually all the variables that go into predicting worry about extreme heat, taken mainly from FEMA, some from the CDC, also socio-demographics over there. And I'm going quickly through this because it's not the super details. I'm just trying to give you insight into how we're doing this work. But the more interesting part are the results, which again are showing us this kind of latitudinal gradient. Now, the reason we did that, we're kind of, in a sense, we're replicating that prior study, but that prior study was just conducted over a single summer in 2015. These results are much more robust. These are results combining data from 5 years. So it's not data in response to a specific extreme heat event. It's sort of like the chronic background trend of increasing extreme heat. This is where people are most worried. People are very worried along the Texas border. Those are the highest levels. All across the Southwest here, majorities in these counties are worried about extreme heat. And then you look up here and you see places like Wisconsin and Michigan and Maine where, you know, maybe 10% of the population up there say they're worried about extreme heat. So, and that validates quite well. So we can now take our model estimates and combine it with the CDC data, and we filled in a little, there were some gaps in the CDC data. We had to impute some values there. But basically now we can take the observed or assessed risk from the CDC Health Index and normalize the data and normalize this data so that we can make them, you know, equivalent in terms of their distribution. We subtract them and then we see the gap. So what the gap is showing you is where counties are red, it means that compared to the national average, people are much less worried about extreme heat, but they have higher exposure or higher heat risk compared to the national average. So these are places where there's a big misalignment. And the misalignment is that people are not at all concerned, but they are at risk. And then the blue areas are where, and we call this an underestimation of the risk. The blue you can consider an overestimation of the risk, but that's, I want to put a caveat next to that term, but the blue is where people are very aware and worried about the risk, but, and there is high risk. So, but the risk is not as high as the level of worry is. And so let me simplify a little bit spatially. What we have now are sort of areas where there's either a big misalignment because people are underestimating the risk or a big misalignment where they're overestimating the risk, at least in terms of the national average. Now, what does this mean for communication? I think this is really valuable because people who are working in a particular city or town have to try to connect with their audience. They have to kind of meet people where they are. And meeting people where they are to educate people and encourage them to take heat seriously is going to vary, because in the South, where there's an overestimation of the risk, people feel quite experienced. And when you talk to people who work in these areas, they say, oh, I know how to deal with heat. Well, I'm prepared. I know this heat. I've lived here all my life. And so they need a different kind of outreach and engagement than people up here in Maine or in the Appalachian region, where you have people who are like, why would I think about heat? They don't have air conditioning. They probably have never experienced a heat wave or don't feel like they've experienced a heat wave. The institutional and infrastructural development to support a response, if there was a bad heat wave in this area, is probably much weaker than it is in places down here, because they just don't have a lot of experience. And we know, for example, the Pacific heat dome that hit Washington and Oregon and BC was really bad, right? 700-800 people died, and the hospitals were incredibly overburdened. And so these are the areas in many cases that need a much stronger response. They need to start planning. They need to become more prepared and engage the public to help them understand that extreme heat is actually deadly. So this is a communication tool, a data set, a device really to support outreach and engagement efforts and to help people know that if they're not, just because you live in the North doesn't mean that you're not at risk now for extreme heat, because that risk is growing. And even if you're used to experience a heat wave in the past, the heat waves that we're going to experience now are going to potentially be worse. They will be beyond our range of experience that we've had because temperatures are just higher than they've ever been. So that's what this work is intended to do, to support communication and outreach efforts. We could look at the data a different way, and it will draw out some patterns. Like we can see large urban areas in the West tend to have high observed or assessed risk and high levels of worry, like Phoenix and Las Vegas. And so communities there are really probably on the forefront. They're probably doing a lot already, and we can look to these communities to see, okay, what works in terms of planning and preparation. But it's the small rural counties in places of the West where they're probably a lot less prepared and equipped. They have high risk but low levels of worry. So more interventions in the rural areas are generally what we're seeing, because this is where you have low worry but high risk in this bottom red quadrant. Places where there's relatively low risk but high levels of worry, maybe some of these places is where innovation is happening because you have the public engaged. So in San Francisco, for example, the risk of heat wave is not terribly high. It's probably over here somewhere. But the public is very worried about extreme heat. And so they have had heat waves, and they opened cooling centers for several years, and the cooling centers sat empty. Because they were very sterile. They were like rooms like this with a few coloring books on the side. Who wants to go hang out in a cooling space like that? Nobody. So what they did was they said, well, where are people going when there's a heat wave already? If we want to make a behavioral intervention, let's make it as easy and frictionless as possible. So they looked for where people were going when it was really hot, and they were going to restaurants, grocery stores, just trying to get into a place with air conditioning, churches, community organizations. And so what the city did was they said, okay, let's find some of these places where people are already going and partner with them and say, we will buy you better air conditioning, air filtration in case it's smoky out, and we'll pay for all this. And in return, you give us your data. Give us data as to how many people are using it. And then we will see how that works. And you can keep the equipment and use it year round. And it was incredibly successful, really successful. They were scrapping together funding, but now it's a system that is being built upon. And that's the kind of interventions that I think we need to see more of, and that might be happening in places like this, where the public is already engaged, or the city and community organizers are already engaged. So hopefully this data is going to support engagement efforts, especially at local levels, because every county, we have data for every county. So that's the advantage of making these maps and going to the trouble of trying to make a comprehensive map and produce a comprehensive data set. I'm gonna skip that. So I'm gonna conclude because I wanna leave plenty of time for discussion. But to conclude, perception is really something that's not often considered because we don't have data about it. It's very hard to understand what's in people's minds when we're talking about these kinds of interventions and communicating about health risks. But we have advances in tools and modeling where if you can do a very large survey and it's the kind of attitude or behavior that is somewhat predictable, we can use these models to start generating more data across the US. And so including perception as a measure of vulnerability, as a component of vulnerability, I think would be really valuable because it does affect behavior. And so in terms of extreme heat, we've now learned that most people are really not very worried. Most of that map was blue. And so there is a challenge there just to help people understand that it really is dangerous. Those with experience are the most worried. Those in the South, those in the North are the least worried. It seems kind of intuitive, but we didn't really know that until we made the maps. And then the places where people are most worried do not always mirror the places that have the highest assessed risk. That's where the gap comes into play. And hopefully these can aid communication efforts once we get them out. So thanks for your attention, and I'd love to answer questions.
Thank you for speaking with us today. I had a question about kind of some of the states that were in the high perception and high, like observed risk, especially in the South. Um, where like there were, some states that like were, well, like most of them slash all like voted, ended up like voting for Trump,
Yeah.
where like governments are not necessarily the most like on board with climate policy and like supportive of like kind of pushing that forward. And I was just wondering what like adaptation and mitigation might look like in those states where like there's not necessarily huge like, political support for it, but there is still like high perceived and observed worry.
I think in the more urban, so are you talking more urban or rural? Because a lot of the cities they're doing a lot, right?
So I guess like in like areas where like they're like more like rural as well.
Yeah, more rural as well. I think that's where the challenge is, and it's probably very spatially variable. Like there might be towns here and there that have a motivated champion for this. But my fear and worry is that there's not a lot happening and that they're not thinking so much about it. I would love to hear from people's experience and maybe is anybody from the Southwest or from any of these really hot areas? We're all sort of cold northerly folks. Yeah, I mean, I know there are lots of case studies and examples of like from Phoenix and Tucson and, but for the rural towns, I mean, I think a lot of it comes down to the particular dynamics in that city office. Is there are there public health folks? Certainly people in the hospitals and the public health community are engaged, but whether they're really thinking about extreme heat, I don't know. I don't have a great answer. But that's what I'm hoping, that even if these maps can catalyze a conversation, because people may not realize that they're in an area that is kind of identified as particularly vulnerable. Because usually there isn't data for some of those rural counties. A lot of the work on extreme heat has focused on, quantifying how excess mortality changes or something in an urban area. Usually all the studies are in urban areas because that's where the data are. And so I think that's one of the benefits of like bringing the rural counties into the conversation.
Thank you.
Yeah.
I'm curious, as somebody who's from like an Appalachian state, and kind of going back to the CDC considerations for like what are risk factors for.
Yeah.
I feel like a lot of like the sociodemographic factors like poverty, unemployment, it's hard to, I guess, envision that for people who like those are a lot more pressing issues. So I feel like it's harder to understand those in the context of climate change. So I was wondering if you had seen any like communication strategies employed in those areas that kind of like contextualize what those factors mean in the context of climate change, if that makes sense.
I think, I mean, what those factors mean in the context of climate change in terms of people's attitudes or in terms of the impacts?
I think attitudes.
Yeah, so we have done some research that shows, one of the strongest predictors in the US is Democrat or Republican, right? But that's not the whole story. So if you're in a conservative area, people are going to generally be more resistant, even if they accept climate change as a threat or extreme heat as a real problem. They're going to tend to minimize it because they don't like the solutions. They involve government, right? And we often find that people in urban areas, which also tend to be more liberal, they tend to have higher education levels, not necessarily higher income, but a lot of those factors do kind of cluster together, right? Liberal, urban, more educated. In the rural areas, communities that are have lower socioeconomic status, for example, they tend to be less worried. They tend to be more independent, more self-reliant. They hold values that are more core conservative values that often can make you just perceive less risk across the board. There's something called the conservative white male effect, which actually holds for a whole range of threats, from environmental hazards, but also things like disease or terrorism or things like that. So they just tend to perceive less risk. But income is not one of those. I think income is kind of cross-cutting. So it's the conservative white male effect. It's not the conservative white wealthy male or poor white male effect. So I don't know how income kind of, because you have the income disparities in the cities as well as in the rural areas. So I don't know if there's a general statement. I'm not sure if I'm getting it all to your question.
No, you are. I'm just kind of thinking about like how, like as somebody in public health, we can better kind of connect these issues individually to the broader issue of climate change. Because I feel like it's hard to think about, you know, like the state of the world and the climate when like you can't afford groceries or like things
Right.
like that.
So there has been some work on an idea called the limited pool of worry, which is the idea like you're talking about. If you're focused on, you know, trying to make rent and pay for eggs, how are you supposed to worry about these other issues? And it turns out it's really not the limited pool of worry, it's the limited or the finite pool of attention, because it turns out that people actually in that situation have just as much worry as everyone else, or even higher worry than everyone else, because they know they're more vulnerable. But what they don't have is attention. They don't have the time to sit and scroll through the news or, you know, to attend events or take classes or something like that. And so I think in that case, it is critical to get the information to people when you can reach them in the doctor's office, for example, right? Like when they're already there, we have to make sure we're working with physicians, with teachers, with the people who they must interact with already, and not try to expect them to do extra stuff, right? Which is true for all of us. Yeah.
So I think triangulating a few of the things that I'm hearing and reading from the students' questions, and I think is the kind of like broad public health question that we're trying to get at is, so you've given us this really cool look into the geography of risk perception and this kind of risk perception gap, essentially. And then you're telling us essentially these response types in each of these places with the 6 Americas. Is there any work, and not necessarily your work, but if you know of any work of like, what do we tell people in those places? Is there any work about intervention to modify risk perception?
Mm-hmm. So I think the big takeaway, and it applies across the board, but especially to people who aren't already alarmed or concerned, is that in most cases, people have not yet heard that climate change is real, that there is no doubt in the scientific community about it, that the risks for things like extreme heat are getting worse. It's the basic facts. And I'm sorry I didn't put the 5 key facts up here, so I will just tell you what they are, because we actually have a 5 key facts slide that is good all-purpose sort of intervention. 1, climate change is real, or it's real, 2 words, it's 10 words. It's real, it's us, meaning it's human caused, it's not natural, which means we can change it. So it's real, it's us, it's bad. I know a warm, you know, increasing temperatures might sound nice today, but overall it's bad. Scientists agree. So 97% of climate scientists agree that the Earth is warming, it's caused by burning fossil fuels, it's bad, by and large the impacts are bad. So scientists agree is the 4th one, and the 5th one is there's hope. There's hope because we actually know what to do to reduce carbon emissions. We know what to do to adapt to extreme heat. We have a lot of tools in our toolbox, but we need to use them and prioritize them. So those 5 key facts, it's real, it's us, it's bad, scientists agree, there's hope. Those are good things for any physician to say, for any teacher to say, and the reason they're kind of meta ideas, because if you accept and acknowledge those ideas, if you believe those ideas, then you're more likely to take the right steps, to take things seriously, to support policies, to adapt or mitigate that are going to be effective. And so there is good research behind all of those. It's not, you know, of course, you don't want to just talk to someone and say, these are the 5 key facts, you know, but those are sort of like the overarching themes. There are a million stories you can tell about any one of those ideas. You can tailor those basic concepts, but if you keep those basic concepts in mind and think, okay, I'm just trying to help you understand why extreme heat is really bad and why it's getting worse, and figure out how to tell that to your local community and the people you're interested in, then you're building an understanding of the danger. So then you run into the question of, but what about all the fear? You know, isn't this just doomerism? And the answer to that is, first of all, most people are not scared enough. And that's what these maps show. We in this room and in this school and in this local area are in a bit of a bubble. Many people here were alarmed, right? We're in the alarm category, most of us. That's not true for a lot of people out there. So especially in places like the North or in conservative areas. So they kind of need to be scared. They need to be more scared. So they need to know what the facts are in a compelling way. And so, but you can't stop there, because then you have to do what you all are asking for, which is give a sense of agency. What can you do to solve the problem then, right? Like, what can I tell people? What can I do? How can I engage? And you need an answer that fits the local community. And one of the most powerful things we can do is join an organization. But that's a pretty big lift. There are a lot of organizations now tailored to youth, tailored to elderly people, tailored to communities and professionals. So you can join an organization, but an easier thing to do, which anyone can do, is really just to kind of get it on the agenda, talk about it, have a conversation about it. And that conversation might be asking someone how they decided to install solar panels on their roof, or why did they go and change their diet and eat less meat? Or, you know, it could be asking about solutions that you've observed or good behavior you've observed. It could be just asking people questions, but it's talking about the reality of our changing environment and how we need to be more prepared to deal with it. So talk about it is 1, join an organization is 2, and I'll leave it there. 2 ways to engage. Yes.
Do you find, or like, do you hypothesize that you would find, like, when you showed the like 5-year, I think, overall background effect of like, yeah. Would you expect to find that people would have different perceptions of extreme heat depending on what time of year you survey them, and like?
So these are combining spring and fall surveys. So every spring and every fall for the past, I think this is like 6 years of data. And there is not a huge difference, interestingly. I'm sure if we ask like during or right after a heat wave, there would be a spike, but the response tends to decay pretty quickly. And so we're trying to kind of capture the baseline. People are really interested when it's happening. About a week after, you're back to the baseline. Yeah.
Looks like there's some questions online.
I can summarize one of them. Let's see. I guess a question that kind of goes well with this question that just happened, which is, do we expect, or has there been any work looking at if there are any particular climate related events that we would see shifts in people's perceptions? The example given here are the LA wildfires.
Is the question, would people react differently because it's a climate related event?
Yeah, essentially.
So that raises the question of attribution. There's a whole science now trying to figure out what can we attribute a specific event to, or can we attribute a heat wave or the fires to climate change? And if so, what about the event? Was it the duration, the magnitude, the severity, the intensity? All of these events are incredibly challenging to even define and scope. So there's a lot of work and it's advancing rapidly, but we already can say things like this heat event was made, 200% more likely or 2 times as likely to occur. So the science is advancing. It has, the public, is responding to those attribution statements. And the science, when scientists can quantify how much worse a heat wave or the wildfires were because of climate change, it makes it easier for the media to make claims. They don't have to add all these caveats and it sounds mushy and it makes people skeptical. So that advancing science is definitely changing the discourse in the media. Which is how most people hear about climate change, is through the media. I think it is probably strengthening people's opinions who already believe in climate change. And so if they're already kind of on board and worried about it and wanting to do something about it, and then they learn that the wildfires were made worse, because of the background drought in California hadn't received any precipitation, the coincidence of the fire season with the Santa Ana winds, there are various factors that can be linked to climate change. So maybe it's persuading people who are persuadable a little bit more. But there are a lot of people who still are not connecting the dots.
Yeah, so related to that, for example, for perceived risk of extreme heat in particular, I see that your data are through 2022.
Right.
So I wonder if there was a big shift in the Northwest US due to the heat that was experienced in 2023. And if you do this again, you'll get a different result.
I think the overall, that is in there. It did go up. It did go up a little bit, but it's not like radically different. I think we will add another wave of data and we'll see that there is a trend. There is a long-term trend if you disaggregate this by a year and start here, there's definitely an upward trend. Yeah. And how much bigger the trend was after the extreme heat event, I'm not totally sure. But I'm sure it lifted more there in that part of the country than in other parts. Yeah. Yeah, people are sensitive. They definitely do respond, but it's often, I think people often kind of misperceive how generalized it is, and they don't realize how transient these events are. They kind of happen and then people forget.
I think we should end there, but
Okay.
thank you for joining us today.
Thank you.